So, what we're going to talk about today is how we at Canonical make sure that Ubuntu offers you the best possible ecosystem of both hardware and software components for OpenStack. And to do that, I'm going to take us through this. I've joined here with my colleague Jason Hobbs, who is responsible for a remarkable project that we're going to talk about called the OpenStack Interoperability Lab, which is at the heart of how we test and validate and guarantee that you can build a cloud of your choice with components of your choice and yet be confident that, that it all works together, that it's all going to come together when you go to deployment. So what I wanted to start with was to talk about what our vision for what OpenStack should be for most users. Okay, when we come to an event like Vancouver, there are always early adopters up on stage who will be doing OpenStack on 100,000, 150,000 nodes, often with unusual network topologies, and it's quite a crafted OpenStack experience. And that is great, and these super users are fantastic for pushing OpenStack forward. It's also true that there are many other organizations here who need to use OpenStack in a much more push-button sort of way. You know, in the end, infrastructure as a service is a commodity, and you want to consume it as cheaply as possible. So we're at the beginning of OpenStack's emergence in standard enterprise, and it's good that everyone's here this week. But frankly, in 2 years' time, really what you want from OpenStack is just that you press a button, it works, it maintains itself, it upgrades when you want to upgrade it. And really, you want to have that to be as push-button an experience as possible. From our perspective at Canonical, you know, if you look at the super users, Comcast, Walmart, who else did we have on stage yesterday? There was, or 2 days ago, there was Digital Film Tree. The good news is they're all building OpenStack with Ubuntu. Okay. But we also want to make it this push-button experience. And the best way I can describe that experience of how well integrated all of these partners and these ecosystem players should be in the OpenStack experience is to talk about Autopilot. So our Autopilot experience is an installer and management tool for OpenStack. And I'm going to talk about it for just 2 minutes and then explain how this links into the partnership part. I can take the installer now, it's in beta, and I literally just name a region on a cloud, and then I get to choose what we think are the most important decisions about how you build that cloud. I can choose a hypervisor, choose a networking stack, object, and block storage solution. And depending on the choices I've made, the installer will say, well, you're going to need, if you want to do that in HA, you're going to need 7, 8 boxes. If you make choices that we think would give you a cloud that couldn't be upgraded to the next version of OpenStack, the installer will stop you. It is intelligently guiding, not just automating any decision. It's saying these are good decisions to make for an OpenStack cloud that you can install, manage, and upgrade efficiently. And what you'll see here is at the moment, there's a limited number of choices there. You'll see only KVM, Open vSwitch, Ceph, or Swift. But the goal of our partner program is that you will have the ability to choose a whole selection of components in there. So both KVM and ESX and eventually Hyper-V. In fact, we've seen a Microsoft partner demonstrate Ubuntu OpenStack based on a Hyper-V as a hypervisor in the last month, a company called Cloudbase. And so you're going to have a choice of hypervisor. For networking, what we're going to demonstrate today is that all of the networking vendors we talk about, all the SDN vendors, they will be there as options in that installer. So you could say, I want to do Contrail, or I want to do Nuage networks, and that will just be a configuration button on that install experience, and so on. As we go to object storage, that'll be obviously Ceph and Swift, but you'll see more traditional vendors in the storage categories and be able to install a plugin to VNX, Viper, Copperhead from EMC. We announced a partnership yesterday with Next Center. So a whole wide array of partners that will be enabled in that installer. And we think that for people running a cloud that's under maybe 300 physical hosts, this is how you should be installing OpenStack by the end of this year. It really should be this this simpler process. And what that installer will do is it will not only do the install, it will then help you manage that OpenStack cloud going forward. So that's the vision of OpenStack as a push-button experience, that you've got choice about what you do. So we're not locking you to one very, very limited build of OpenStack. You've got choice, but we are guaranteeing that you're on a known good configuration that's critically that is upgradable. Why do we hark on about upgradability so much? How many people in the room have done an upgrade of OpenStack from one version of OpenStack to another on a production cloud? On a production cloud. How was that experience for you? Hard. Yeah. How was that experience for you? Sorry? A work in progress. Okay. So some scars, but okay. Which version did you upgrade from? About to Juno. And which versions were you upgrading? Okay, a while ago. That's the vision for how to do it. The reason we hark on about upgradability is because the killer functionality of OpenStack, as you will have all noticed from being here this week, is that it's moving so quickly. The best feature you will ever get from OpenStack is the ability to upgrade in place. And so that's why we're so focused on that upgrade story. So as an install process, does that look like something that would be interesting? You know, if you wanted to experiment with OpenStack quickly or get it set up, would that be an experience you would want? I'm seeing some nodding at the back of the room. Okay, so how do we get there? Underneath the hood of Autopilot, we're using two tools. One is MAS, Metal as a Service, for doing bare metal provisioning, and the other one is Juju. And Juju is acting as a universal model for all of the services that are in OpenStack itself. And here you can see, for us, a typical HA deployment of OpenStack, and we've got it running there with Nuage as an SDN. So what's critical here is for us to be able to deliver that guided install journey, we need partners to have taken their solution and to charm it up into what we call a Juju charm. And once we have that, we then have the ability to do an automatic install with any partner component. So you can see that if we had different architecture here, I'm swapping out Nuage for an architecture where we're using Calico, which is a layer 3 SDN from Metaswitch, who also do the project Clearwater. And all I'm doing there is that the architecture is staying exactly the same, and I'm swapping out the SDN vendor. So what's important for the partner is that they've taken that component, they've charmed it up, and then that gives us this ability to automatically build a cloud with their component installed. To do that, to give this ability to integrate lots of different solutions into OpenStack, we need to address this hard problem of interoperability. Okay, so the beautiful thing about OpenStack is it gives you lots of choice, and with that choice comes this cost, which is, can we deliver that flexibility with high quality? And the solution to that is something called the OpenStack Interoperability Lab that we set up over 18 months ago. Dan, correct me if I'm 18 months ago, is about right, in Boston. And it is the largest interoperability testing facility for OpenStack in the world. Okay. It's been going for 18 months. It's fully automated. And what we're doing there is we are taking permutations of how you'd build OpenStack, so at its very base layer, compute, storage, and networking, and starting to map out all the different permutations. So someone here, may be doing KVM, Ceph, and Cisco Nexus as an SDN, but somebody else may be saying, actually, I want to build with ESX, NetApp, and Juniper as my options. And you can see very quickly we're going to start getting to quite a lot of permutations here. When you start then layering on top of these hardware, these component permutations, if you then start adding in version permutations, so going from Icehouse and Juno, we start getting into a really big automated testing exercise. And that is the work that happens in the OpenStack Interoperability Lab. So just to give you an idea of where we are at the moment, there are over 30 vendors who pay to have their equipment in the Interoperability Lab. This is not a logo swapping exercise. This is how do we as an ecosystem guarantee to you as users out there that these things will work together? How do we ensure that we spot issues with tip between, suddenly discover that Ceph and Juniper on ESX are not working well together? How do we make sure that information is going back to vendors in a timely fashion so they can fix those issues? So just to hit you with some numbers, over 73 hardware combinations are in oil. We have over 175 different combinations of how to build that cloud in terms of which services from which vendor. We build automatically over 3,500 OpenStack clouds a month. Okay, so hugely automatic, largest testing exercise. That's over 46,000 OpenStack deployments. And since we started the lab, it's over 1.3 million functional tests have been run. So we're doing this at extraordinary scale. If you're a customer, one of the things we will always do in our first meeting with you is simply say, what are the combinations that you are either have deployed or are thinking about deploying? So a lot about this is then reaching out to new vendors and making sure they've got their equipment in the lab and that they've given us both the solution that they have that needs to be tested, but also functional tests around it. So if you're Juniper Contrail, for example, you give us functional tests on top of Contrail that prove that Contrail has correctly come up and is functioning. And as part of the automated infrastructure and the test, we will bring up that cloud and then start running your functional tests as a partner on top of that. So maybe to talk a little bit more about how that happens in practice, I'll hand over to Jason, and you can maybe just talk through how the lab is set up.
Sure.
For the room.
Okay. So this is all based on Ubuntu OpenStack, of course. So we're deploying Ubuntu OpenStack, kind of our core components, along with our partners' technologies, whether those are hardware or software-based or a combination of either. So this is all completely automated. At any given point in time, we've got about 12 clouds either under deployment or under test. And the way we do that is using Juju and Maz. So we use Maz for managing the bare metal layer and use Juju to kind of coordinate what Maz is doing. We've got around 150 servers that we're deploying OpenStack onto. So like I said, by any given point in time, we've got about 12 clouds being deployed or tested. And so the way it works is we've got a piece of software we call our queue master that looks at all the possible combinations of OpenStack services and picks a combination and submits it to, we use Jenkins for running tests, so submits it to Jenkins, and that gets Juju and Maz kicked off and deploying OpenStack. Once OpenStack is up and running, and it's ready to use, we've got a second stage we call prepare that configures OpenStack for use. So it sets up networks, adds users, uploads images to Glance, and gets it ready for actually using and testing with. And then after that, we've got a testing stage where we run Tempest, and we run any of the tests that partners have provided to run against their technologies. And so once all of that stuff is done, we've got a kind of an analysis stage where we look through all the logs for the deployment. We look for signs of failures, so tracebacks, failed tests, and things like that, and identify bugs. We can classify bugs by whether or not we've seen them before. So if we haven't seen a bug before, we can flag it and have an engineer go and investigate the source of the failure and figure out what went wrong. When we find bugs, we'll report those to partners if they're bugs with partner technologies. And then, so kind of all of those results from each of those runs, it gets, we save them into Swift. We keep them forever. And on a monthly basis, we'll go and pull all of the results for each partner and generate a report for the partner that says kind of which services did they deploy with, what combinations did they deploy with, how many times did they deploy, what kind of failures were involved in their deployments. So we'll send those out on a monthly basis. So that's kind of how it works. It just keeps going constantly, 24/7. We do about 150 deployments a day. It's pretty cool.
150 OpenStack clouds a day. Is anybody doing that many OpenStack clouds a day internally? So questions about how we're running that lab in the room. Either partners or customers who've got questions about what's happening in the lab and the tests that we're doing. Go ahead.
Do we have to have a hardware there to better certify or to get this interoperability certification?
Yes, it's a simple answer. So the question, I don't know if people can hear it, is does there have to be hardware in the lab to do the testing? So obviously some of the components in the lab are software, but if it's a hardware component, we absolutely need to have the hardware permanently in the lab. And in fact, you touched on something I was going to jump to, which maybe I'll just jump to, here we are, which is the difference between hardware certification for Canonical and being in the lab. So here we're talking about continual integration of all of these components with each other. And for us, it's a separate thing from hardware certification. Hardware certification is typically a relatively one-off part of the process. And actually, I thought I'd bring this up on screen. If you can, there we are. So that is looking at a matrix of certified hardware for Ubuntu itself. So this is not in the lab. This is looking at Ubuntu itself. And there you can see from HP that you've got over 41 servers certified with 1404, last LTS, and 64 servers certified with 1204. And you can see that a subset of them, only 9, are actually in the lab. Okay, so to be in the lab, we need to have the hardware because we are testing every day. We're also now starting to pull down the daily build of OpenStack, next release, tip, and testing that here. So we're giving the vendors very early warning that there's an issue with a commit that's going to break some of their compatibility. So the answer here is if you want to be in oil and you want to be part of that program, you absolutely have to have that hardware in the lab permanently. And yeah, it's a simple answer.
Didn't get very well why there are, for example, for HP 41 and then in the other are only 9. Is there separate, different certification? There's the certified to hardware and then the oil certification.
That's absolutely right. So here, if I look at this particular ProLiant device, it's certified with Ubuntu. So that means you've got to remember at Canonical we're also we're operating system company as well as OpenStack. There are 50 people in Taiwan. We've got employees embedded at HP, Cisco, and Dell badged on site. Every time they come out with a new piece of hardware, in fact pre-production hardware, we're certifying that with Ubuntu itself. But a one-off certification of a server is different from continually testing it with all of the other components. And so it is a different program, and the vendors, the partners have to engage very proactively in it. In a sense, having your hardware in oil is interesting but not enough. What you actually also have to do is then be willing to take the feedback every month, detailed feedback, and actually start getting through the issues that we're discovering, the bugs that are being discovered. Which company are you from? Hitachi, okay. And I know there are some conversations going on there.
If I want to enter in this certification problem, firstly, until we get a range for the oil certification, what is the process to get into this certification? I don't know, maybe have to run some tests in-house and then send you some results?
Perfect question. So 3 things. So firstly is engage with us directly. So we have a dedicated team that run oil from a business development perspective. So make contact with them. What we're looking for you is hardware availability, test harnesses that are specific to your Cinder plugin or your particular hardware. There is a financial commitment to actually help run the lab. So this lab is funded by all of the vendors that are in it. Canonical makes a contribution, but most of the funding for it comes from vendors, and that's what you need to do. So we happily talk to you after this session about how to get that in there. So does the difference between hardware certification and oil participation make sense to people in the room? That's clear. Okay. So let's talk a little bit about what you get then as a vendor out of that. So you will get a sort of 30, 40 page monthly report from us. You get live, we'll give you all of the bugs in Launchpad so that you can start dealing with issues live, or you can wait for the consolidated reports. Sometimes the consolidated reports add more insight. I mean, a lot of stuff here fails, and so some of it's about statistically tracking whether or not a failure rate is significant or not. It's not purely just a green-red on functional testing. Sometimes it's analysis of overall whether or not the failure rate is what we would expect or not. Once, so to give you an idea of people who are in that, that's a present subset of partners. Sorry, that's a present list of partners who are in oil. And it's everyone from compute, networking, storage. Increasingly, we're now also starting to see vendors who've got plugins to OpenStack, which are not core OpenStack, but companies like Taligent, for example, who have a really great billing system where that plugs into Ceilometer, who also want to get test feedback on how their component is behaving across multiple different architected clouds. And we're seeing them come in there. So any questions on current partners? Is there anybody who's using Ubuntu OpenStack out in the field who says, oh my word, I didn't realize that my main supplier is not on that list? Or any questions on that list? Okay. So partner reports. Obviously, there's a detailed report. I pulled this as just a summary page. HP allowed me to share this, but this is the sort of report you'd get back. Obviously, the number of clouds were tested on, which configurations, which specific OpenStack services we're testing, which aligns pretty well with DevCore. And then also, we are testing both Red Hat, Oracle, and Ubuntu guests on top of those clouds. It is unusual for the guest to throw up a particular problem with a cloud, but we are doing that testing in case that it does. And you can see here that for this particular report, which versions they're getting feedback on, and also obviously which services are being tested in that environment. So very structured setup.
So the previous slide, does the vendor have to support all the different options? Like say, if I'm a storage vendor and I just have single driver and just test this in the file.
So in a sense, that's what you care about. But if it turned out there was a Cinder keystone, I mean, I can't imagine why there would be a Cinder keystone. We're giving you the full data. It may well be that in the report you just assume that anything that's error outside of Cinder is not your problem or unlikely to be your problem, and we focus in on just the Cinder issues. But we give you the full suite.
Are you only testing stable tags? Or are you testing commits? Like, what are you running?
Great question. So up until now, it has been. Well, do you want maybe to answer this?
Yeah, sure. We're testing out of the Ubuntu Cloud Archive. So we start testing new OpenStack releases before they come out. So we started testing Kilo about a month before it came out, and then as it comes out and gets released into our where we package a stable OpenStack releases, we test out of that. So it's the same stuff that you would pick up if you're installing as a user, installing Ubuntu OpenStack.
I'm going to do a little demo in a second, so give me a second. Any other questions in the room while I just get this little demo? So the question is, what are we doing for server certification with someone like HP? Yes.
So, yeah, we've got a kind of a standard suite of tests that we run. There's tests that run on the server. So we have to, in order to certify, we've got to get one of your servers, or sometimes we'll do remote testing or go on site. But usually we'll get one of our servers in our lab, and we've got sort of a standard test suite that checks things like, does storage work? Does the network work? Can we install? Does that work? We also test with MAS, so whether or not MAS can control the system. So that kind of certification process kind of clears the way to get into oil. If your server gets certified, then we know it's going to have a good chance of working well in oil, given we use MAS to control everything in oil.
So we can't hear you.
So the question is, as a server vendor, you have choices of storage adapters or network adapters in your servers. So I think typically, and I'm not an expert on certification, but I think typically we want, since there might be differences in functionality with those different storage controllers, or it might work with one and might not work with the other, we want to have separate certifications for each of those, each of those different models that has different components in it like that.
Yeah, so there's a dedicated hardware server certification team. They'll have a matrix of things they do and don't care about. Obviously, a bit of extra RAM is unlikely to make a big difference, but maybe a different storage controller would, and they will work with. So which company are you from? Sorry? QLogic. So the certification team will work with you and decide which variations they would want to see a new piece of hardware for in the certification lab, and which ones they'll just accept are statistically unlikely to be an issue. That's a well-oiled machine. The hardware certification teams have been going for sort of 6-7 years, and there's probably 60 people in it. And would your team be operating out of the US or out of Taipei? Okay, so we can. There's hardware certification leads in both markets, and we would hook you up with them. So we happily talk after this session. Okay, I wanted to just do a live demo in a second, so I've got that set up. So where does this get us to? So you now know you've got confidence that you can build a cloud of these different components. Well, something that a lot of you might be doing. Who is here is evaluating an SDN this year? Anybody looking at SDN evaluation this year or making a decision about SDN? People are holding off until next year, is that right? Okay. A lot of our large customers right now are starting to make decisions about SDN. To do that, you really need to have it connected up to a cloud, and doing an SDN evaluation might take you a week or two easily to get set up. So what you're now able to do by taking the charms that we're using for these automated builds in OpenStack is you can now get from the vendors those charms, and we can give you validated known architectures of an HA OpenStack cloud with any SDN vendor. And you're literally able to drag and drop the service description YAML file from Juju onto a new cloud, bare metal rack of machines, and have that architecture built automatically for you. And that could be Nuage, it could be Calico, it could be, this is Cisco who funded the work around an Open Daylight integration with Ubuntu OpenStack, or it could be Metacora, PlumGrid. There's a whole set of SDN vendors all coming in the next 4 or 5 months into the lab. And in fact, if we go live here, I will bring up, bear with me a second, I'll bring that up on screen. Right now, here I've got in front of us 2 orange boxes. So here there are 2 orange boxes, which, for those who don't know the orange boxes, they've got 10 Intel i5s in them with shared storage and a switch, so it's a data center in a box. And here on this side, what we've got is Juniper Contrail installed on that box. And I am able to take, that's running on that device. You should have 10 lights on the front showing that all of those boxes are on. And in fact, I can take that architecture, and if I wanted to share that with somebody else in the organization, I can export that. I then get a simple YAML file which describes that particular architecture. Let me make that a little bit bigger. And that is describing, in a YAML file, all of those services, and I'm able to then give that to a colleague with all the relationships set up, and I can literally just go and build that on a fresh install. So it's completely changing the speed at which you can experiment with different SDNs, and we've got known good bundles for all the vendors I showed, with another 4 or 5 coming in the next couple of months. So if you're doing an SDN evaluation project, this is the easiest way to be. All right, so onto the other orange box, where I want to do the install of using the Autopilot. So putting this all together. Here we are. Okay, so let's have a little look. So on this orange box on the left from where you're sitting, you will see that we have hopefully one. What you'll see here, if if you can see at the back, is we've got Metal as a service looking into this box, and it can see 10 physical nodes, and you can see that only one of them is deployed, which is this physical node here, and that should correspond on the front of this little box to that one light that you see here. So one physical node, and it's got the installer app that we're going to look at right now installed. The other 9 nodes are completely blank right now. There's nothing on them, no operating system. And now what we want to do is we want to build our cloud. So I'm going to log in to that node that has the installer. And actually, who here has not installed OpenStack before? Have you installed OpenStack before? You have. Somebody who hasn't done OpenStack before? Come on, hands up. Don't be shy. I'm going to pick on you because you're at the front. Do you want to come up on stage? Yeah, come up here. We want to build a cloud. We're going to build a cloud live.
Well, last time I installed the Ubuntu Cloud, it took like 2-3 weeks.
2 or 3 weeks?
Yes.
Okay, let's see if we can do that a little bit faster, because I know that people have got coffee to get to in about 10 minutes. Okay, so we just need to give this cloud a name, so feel free just to give it a name for the region. What is your name, sorry?
Erlon,
Erlon. And where are you normally based?
Brazil.
In Brazil, Brasilia. Fantastic. That's a good name. And we sort of, do you want to call this, we can call it Cloud 1, or you can call it something else?
Yes.
Okay, so we want to choose a hypervisor. So if you just go down, you'll need to use the pointer.
Yeah.
Yep. Choose KVM. That's pretty simple, so just select. We've only got Open vSwitch available, but soon this will have Juniper Contrail and Nuage networks will be embedded in that installer. I need to put a gateway network in there, don't we, Doug? Yes. What's in your IRC window? And it's in the public gateway there. I believe we have that. There we are. Okay, so I've just added the for getting out on the public network. So select the rest of it. Yep, select. That's also populated by having discovered what's on the device.
It's not in the same network. I think you got the 27 instead of 72.
It's 27. I put the 7 in the 2.
Ah, typo.
It's not 27.
Can you get there? There we are, 27.
Nope.
Yeah, he's good. Yeah,
And a dot, I think you lost.
because he was smart enough to detect that you
Yep.
got it wrong, so that's good.
Yep. Okay, so let's go down and select. Let me to help you on the. Sorry, it's the ThinkPad, Revenge of the ThinkPad pointer. There we go.
Okay.
We're out of time, I think.
Okay,
Yeah.
and I will select.
You have a space in the other side.
Thank you.
Space.
There we are.
Need to trim that.
Okay. Then Ceph or Swift as you see fit.
And
We're just going to add hardware. So I'm going to just do this quickly because we've got people coming in. There we are. And we will need to add a little bit more hardware. And we didn't make it.
One more time, Chris.
That's it.
Yeah, there you go.
And then install. And that is now kicking off. And for people who are staying for the second session, where we're going to talk about how LexD crushes KVM, you will see on that left-hand box that the lights will start whirring, and before the end of the next session finishes, you'll have a full OpenStack cloud that you've just done live on stage.
Great.
So thank you to Erlon.
how long for this?
That should take about 20 minutes. Thank you very much. Okay, so that's us wrapped up. Thank you very much for joining us on Oyo.